So first and foremost, good day, and thanks for giving this video a quick view. I'm Mark Christie, one of the Senior Systems Engineers here at StorMagic, and during this video we're going to get StorMagic SVSAN set up on two Lenovo System X 3250 servers. SVSAN enables a Network RAID 1 shared storage solution using the internal disk of the ESXi or Hyper-V hosts. SVSAN's software-defined storage capabilities enable a lean IT, hyper-converged environment to provide the best return on investment of IT hardware. Starting at just 2 nodes, SVSAN enables a cost-effective, virtualized architecture for SMBs and SMEs, as well as the distributed enterprise. For the next few minutes, we're going to detail out the steps involved to get up and running. This video, alongside the Lenovo implementation guide, and StorMagic's freely available online manual should answer any queries that you may have. However, should any assistance be needed, the StorMagic support team are keen and happy to help via email at support@stormagic.com. First, we're going to complete some basic configuration prep work in order to configure the servers to fit StorMagic best practices. This environment is running VMware. However, the steps are very similar with Hyper-V 2012 hosts as well. StorMagic and Lenovo have partnered together to build reference architectures on X3250s, which are single socket 1U rack servers, X3550s that are dual socket 1U, as well as the higher end X3650 dual socket 2U server. All of which, alongside SVSAN, will provide best use of the capacity gap in modern servers to give the best total cost of ownership possible by lowering the total cost of entry into that virtualized environment. So let's just detail out the equipment we're going to use. We have 2 matching X3250 M5 servers with a single socket Intel quad-core CPU. SVSAN utilizes VSAs, or virtual storage appliances, to manage the host storage and create a synchronously mirrored Network RAID 1. To do this, the VSA will reserve 1 vCPU and 2 GB of memory. There will be 1 VSA per host, leaving us 7 vCPUs per host, or 14 total, and 60 GB of RAM for our guest VMs. SVSAN utilizes internal server RAID with all RAID types supported, enabling servers to be sized quickly and easily. Existing customers mirror as small as 300 GB all the way up to 150 TB of storage. In this configuration, we have 3 600 GB SAS disks and a 222 GB SSD. StorMagic best practice is to utilize internal RAID, such as 10 or 5. However, as this host controller doesn't have the cache module and battery, so parity RAID write performance would be slow, as well as us having an odd number of disks, we're therefore going to configure these disks using a RAID 0, which is also fully supported. This will then rely on SVSAN's mirroring to provide storage high availability. The Lenovo CRNs that StorMagic have worked to provide enable different RAID configuration options based on the customer preference and capacity requirement. However, the principle of the configuration is the same regardless of disk count or RAID type used. With this example setup, we have ESXi running on an internal SD card, and we're going to configure the host RAID via the Lenovo IMM tools, showing how powerful the remote management features of the Lenovo hardware are. First, via the RAID controller BIOS, we clear any existing configuration and create our RAID 0 using the Create Virtual Drive Advanced option. This will enable us to create 2 virtual disks on one underlying RAID device. In this case, we'll create a 50 GB LUN that will be formatted as a local VMFS on each host. This local VMFS will hold the VSA VM files. The remaining space will be a secondary virtual disk, in this case of 1.6 TB, unformatted, enabling this to be handed to the VSA to be managed as an RDM. We'll also create a single disk RAID 0 from the SSD, or alternatively put him into JBOD mode depending on the controller, to be handed to the VSA as an RDM as a cache device. We repeat this drive configuration on the other host, so the two match. SVSAN can mirror between disparate hardware, however will operate at the speed of the slower host. We can see the finalized controller configuration. This configuration was completed using the server BIOS. However, in newer Lenovo offerings, this can be completed via the IMM web interface, and this process is detailed step by step in the StorMagic Lenovo implementation guide. Although assigning storage to the VSAs to manage and mirror via raw device mapping is StorMagic best practice, virtual hard disks such as VHDs, VHDXs, or VMDKs are also fully supported. Host configuration options are detailed in the StorMagic online manual. However, should you have any issues, please don't hesitate to reach out to the StorMagic support team at support@stormagic.com. With the hardware configuration completed and matching in both hosts, we get the host booted back into ESXi and format our 50GB RAID LUN with a VMFS. In this example, I have used localhost 1 and 2 to distinguish this from our highly available mirrored storage. However, any naming scheme is valid. This 50GB LUN will host our VSA VM files, and these include the 512MB boot VMDK, as well as the 20GB journal device, as well as memory swap files. The journal disk is only utilized by the software while a mirrored volume is out of sync. Metadata changes are stored to enable a quick resynchronization of the volume when the opposite node comes back online. Should a node be down for an extended period and the journal drive data wrap, the software will simply revert back to a full synchronization of the mirrored target. The remaining RAID LUNs are left unformatted, ready to be mapped to the VSA during deployment as a raw device mapping. This prevents file system layering, so provides a small performance improvement, and is also easier to administer. VMDKs can result in the underlying VMFS presenting alarms due to used capacity, even though the represented mirrored storage has plenty still free within it. If assigning storage to the VSA as a virtual hard disk, the deployment wizard will automatically set this disk to be an eager 0 thick provisioned, as per SVSAN best practice. With the host storage all set up and ready, we next configure the host networking. X3250s have a standard of 4 1GB NICs, and in this configuration we'll be reproducing the shown networking, with 2 NICs providing virtual machine networking and host management into production switching, and the other 2 directly connected between the 2 hosts for SVSAN mirror traffic, iSCSI and vMotion traffic. This is just an example to enable a lightweight and resilient interconnect. However, more complex networking with VLANs, LACP or Ether channel are all fully supported as well. Please note that as we create these vSwitches, they could be shared with other traffic, as well as the fact that due to them being directly connected with a crossover lead without a physical switch, I'm using separate virtual switches and IP subnets so the host routing tables don't have any issues over where to send the traffic. SVSAN licenses storage based on the used mirrored capacity, so sharing or mounting of an SVSAN mirrored volume to a compute-only node is completely free of charge. This enables easy scalability of compute. In my configuration, a physical switch to the compute-only node would need to be introduced on the iSCSI subnet, or the storage shared out over my front-end networking. A mount wizard from the StorMagic plugin makes this process quick and easy to configure. If we wanted to scale within the hosts with this configuration, I would need to carry out a staged disk swap between the servers as all of my bays are populated. With larger hosts, we can simply grow the RAID volume SVSAN is managing via the Lenovo IMM, and then grow the target and data store via the StorMagic tab wizard, all of which is seamless to virtual machine servers. Next, we confirm we have SSH enabled on the VCSA, as well as the hosts for deployment of the SVSAN VSAs. Once deployed, SSH can be disabled if desired for security. It is only needed during the deployment process. With the preparation work completed, we can then carry out the installation of the StorMagic plugin to our centralized vCenter. In this case we're using the VCSA, however a Windows vCenter is also fully supported. In both cases we run the installation files directly on the vCenter that will deploy our own web server, quorum service and plugin integrating directly into vCenter to provide single pane of glass and potentially centralized multi-site management features. With the VMware vCenter appliance we use a bash script, so we first copy the file up to the appliance, and in this case I'm going to do that with WinSCP, a freeware piece of software. We can then select to install the integration toolkit, as my managing vCenter is separate to this cluster. So I can therefore deploy my NSH or quorum service to this machine. A 512 meg NSH appliance is also available if you wish to separate this from the vCenter, or if we want the vCenter virtualized on top of this cluster. The key benefit of SVSAN is the resiliency that is introduced versus physical storage. SVSAN introduces storage high availability alongside compute high availability. We effectively end with 2 SANs and 2 compute nodes collapsed into these 2 rack servers. This protects against unplanned failures such as CPU, memory, controller or disk, but also enables seamless updates to hardware, firmware and hypervisor versus a physical SAN update being a downtime operation. Everything is duplicated across the 2 nodes. We have CPU, memory, controller and disk with no single point of failure. With the plugin installed, we can then deploy the VSAs directly from the vCenter plugin. SVSAN's management components appear at different levels within the vCenter. From the home page of the vSphere web client, we can see the StorMagic dashboard. This will display all VSAs managed by this vCenter, sorted by their health status. This easy-to-view traffic light-based system provides a one-glance overview of the statuses of all VSAs managed by this vCenter. On each data center within the vCenter inventory, we can then see our StorMagic tab, enabling wizard-based deployment and administration tools. This only provides visibility or manageability of objects beneath that data center. This provides a means for multi-site customers to manage ESXi hosts on a per-location basis, with a data center object per site. The largest SVSAN customer to date runs the software in approximately 2,500 locations in this manner, with Site 1, Site 2, 200, and Site 2000 displayed in the vCenters based on geographic location. This enables them to simply select the site they wish to manage, and in their case they also run our NSH appliance in a centralized location. This virtual machine uses 512 meg of memory and a 512 meg VMDK to provide a shared witness quorum for thousands of locations. Our first step in deploying the VSAs is to enter the host root password. This enables the StorMagic Task Manager to authenticate to the host and also get saved into the VSA to provide the software visibility into that underlying ESXi host. This enables visibility into host networking, hardware status, and most importantly, triggering iSCSI software adapter HBA rescans direct to the ESXi host to ensure full path visibility. This ensures that no manual intervention is required after hosts have been up and down, for whatever reason, be it firmware or a host restart. We next accept a license agreement and set the VSA hostname as it will appear within DNS. This name will need to be resolvable alongside the ESXi hostnames if they're added to the vCenter by their hostname. SVSAN does support the ability to run without DNS in an all-or-nothing approach, so would require hosts to be added to the vCenter by IP address if we're looking to run without DNS. We also set on this screen the data store that will host the VSA VM. In our configuration, this is our 50 GB local data store. Next, we can map up our storage to manage and mirror. As mentioned previously, this can be any direct attached storage. However, in our small lean environment, we have our Virtual Disk 1 magnetic RAID that we presented up from the controller of 1.6 terabytes available. Should this configuration not be an option, you can easily use the secondary toggle box to enable configuration with a VMDK on an existing VMFS data store. The Advanced Options box enables the handing up of multiple devices. If, for example, a slower SATA RAID LUN alongside a faster SAS RAID LUN is to be mirrored across to a matching host. Next up, we can hand up our SSD cache device. This is optional, with some customers mirroring purely magnetic, others, like in this configuration, being hybrid, and still others running underlying flash-based RAID. SVSAN is designed to provide flexibility to support all of these different use cases. As our architecture is mirrored, we can run as small as a single SSD, with the flash disk in the other host node providing our high availability. This could also be a flash-based RAID, or the SVSAN software can mirror two SSDs internally within the host should a simple non-mirrored target be being used to provide cache protection. As can be seen, we can also skip this step if a hybrid environment isn't in use. We now configure our VSA networking, with the wizard automatically creating an interface on each vSwitch virtual machine port group available to the host. Just uncheck any we don't want an interface on. In this config we have just the three, and are able to quickly set static IPs alongside setting the relevant flags on each interface. SVSAN will share storage out over any iSCSI flagged interface, and automatically load balance mirror traffic over any mirror flagged interface. We then set our license key, and the VSA will try and automatically connect out to the internet to licensing.stormagic.com during deployment to license itself. However, if the VSA does not have internet access or DNS, offline license files can be downloaded from the licensing.stormagic.com website from a client machine to upload to the VSA after deployment. We set the VSA password and the deployment will commence. This will push a 100 megabyte OVF file to the host, enabling this to be done locally or from a centralized location over the WAN. The VSA will boot up and try and communicate back to the vCenter on the StorMagic Discovery Service port number TCP UDP 4174. This service doesn't cross broadcast domains so as not to generate unnecessary traffic, so if the vCenter is in a different subnet to the VSAs, such as multi-site deploying over the WAN, then static IPs must be used so the software can automatically create the static discovery entry back to the vCenter. Up to 10 VSAs can be deploying concurrently, and this process can be fully scripted via the SVSAN PowerShell command toolkit as well. We then repeat the same process for the second VSA. With both VSAs deployed, we can then create our mirrored volume. First we select the two VSAs to create our mirror between, as well as the mirror size and name. Special characters in this VMFS name aren't supported, as this is also used to create the iSCSI target within SVSAN, and the iSCSI RFC doesn't support special characters. If desired, the VMFS can easily be renamed post-creation. We can create one large data store, or carve the VSA presented storage out into multiple smaller data stores. We select the quorum witness for the VSAs, whether to enable caching on this volume, the hosts to mount this data store to, and complete the wizard. This automates the whole task for us, creating the target, carrying out a full synchronization to guarantee data integrity, collating the host IQNs into the target ACL, as well as populating the VSA iSCSI interface IPs into the software initiator send target list, rescanning the hosts to discover the LUN, and eventually formatting with a VMFS. Once the data store is available to both hosts, it is ready to be used to host virtual machines, and once synchronized, we're in our fully HA state, with everything duplicated, CPU, memory, controller and disk in each box, with no single point of failure, providing compute high availability as well as storage high availability. Thank you for listening.